Okay, so we're back and we're going to be taking a look at our Google Doc. Now, keep in mind that you're going to have to open up the Google Doc that you've already been working on. This is the one that's for Unit 5 for the kinetic molecular theory. And so you could have it where you just simply go here, have it where you click on these dots here, click on Docs. And then what you would do is after you click on Docs, then have it where, you see here the name of it, obviously not Miss Peach, but you would have it where you look up Unit 5. I'm sure if you even just have it where you looked up Unit 5, that would probably be enough to be able to pull up your document that you've already been working on, or Unit 5 student note package, whatever. But have it where you look up parts of the title that I had of the original document, and you should be able to find your document quite easily. Now, with that being said, we're looking here, and so this first part here is talking all about the expansion and contraction of materials, just like what we already talked about in the Google Slides presentation there. And I have a little video here as well, and this is where she explains just what that means to be able to have expansion joints and just how the contraction and expansion of materials work. And so you can take a look at that one quickly. And then here we're looking at this video, or not this video, we're looking at this picture. And so I know it's a little blurry, but you can kind of make out the fact that we have some different materials on the left side here. We have porcelain, we have plate glass, we have wood, we have steel, concrete, brass, tin, and lead. And what happens is they're having it where they're showing that this is the original length of all of these materials, but if you expose it to heat, then what will happen is this is how much it can expand when it is exposed to the same amount of heat. So as you can see, porcelain does not have much of an expansion rate there. Lead has a lot. And so now we're just take a look at the questions that we have here. So it says, which material expands the most upon heating? Well, if you're looking here, you see that it's definitely going to be lead. That is going to be the one that expands the most upon heating. And then which material expands the least? Well, that's definitely going to be porcelain. Oops, gotta watch my spelling. Oh my goodness, it's getting worse. Okay, porcelain. If you're finding it annoying, like I am kind of, where it's not, yeah, where it looks exactly like the question, then you can just get rid of the highlighting. You don't have to if you don't want to, but for me, it's nice to look at what is my answer and what's not. Okay, now it says, which solid would be the best material to reinforce concrete? So what you're doing is you want to look for something that's going to have more of a similar expansion rate to concrete. So something like plate glass or even wood has a much smaller expansion rate compared to concrete, whereas something like lead and tin, that actually has too much of an expansion rate. And so I know brass is also fairly close, but if you take a look here, you still see that between concrete and brass, you see that there's quite a difference there and just the amount that it'll expand. Whereas if you look at the steel, that is a much smaller change. So for this question here, it actually would be steel. Steel would end up being the best item to use to reinforce concrete. And then here it says, a man built a house with large windows set in beautiful frames made of brass. The house is in a region where it gets very hot during summer. Imagine that the owner of the house has a problem. The windows of the house look beautiful in their shiny brass frames, but they keep falling out during the summer months. That would definitely be a problem because windows are expensive to replace if they get cracked. As a scientist, how would you explain this, and what would your advice to the owner of the house be? Should the frames be replaced? If so, with which material? What other solutions can you suggest? So, taking a look at this here, now we see brass and we see how much that expands, and we see with glass that expands a lot less than brass. Take a look at that. And so that means that during the summer months, what's happening is the brass is expanding quite significantly as the heat rises outside. Whereas with the glass windows, it actually doesn't expand that much. And so it's significantly less when you look at that. And so, of course, they're going to fall out because you need to have a material that's perhaps a little bit better with matching the glass and expansion rate. So what I'm going to do is I'm not going to answer this question here. What I want from you is I'm going to put this question in your Google form. I want your best ideas here. You're going to refer to this picture, obviously, and then you're going to have it where you come up with your solutions. Are there other solutions you can offer? So you can come up with at least a couple different solutions. Get creative with that, but keep in mind this whole diagram here. Make sure you keep that in mind, please and thank you. Okay, so now we're going to move on here, and we're looking at this metal ball that's here and the ring apparatus. And so what happens is they're both made of brass, and so we also know that at room temperature, everything is going to go through easily, no problem. Now, what will happen if just the ball is heated? So is this going to be able to still fit through here? So keep in mind the question. It's not asking if both are heated, will it be able to fit through? They're saying, what if it was just the ball that was heated, just that? And will it fit through this apparatus anymore? So you need to answer that question there. And then I'd like you to be able to answer that in your student document there. This one here, you're allowed, you for sure, go ahead and answer it here as well, but this one will be on your Google form homework check. So do you think the brass ball will have more mass when it has expanded? So obviously they're kind of giving you a bit of a clue here that the brass ball is going to be expanding as it's heated. So then, no, oops, it will not fit through the ring. So it's not going to fit through the ring when it is heated, just the brass ball. But can you tell me, is it going to have more mass when it expands? So if a material has expanded, what do you think? Is it going to have more mass? And so we're just going to take a quick look over here. And so obviously looking at the slideshow here, it says that no, the ball expands when it's heated. It's not going to fit through the ring. And then, one moment here. I'm actually going to go back to the Google Doc here. I realized I got a little ahead of myself here. Now, I'm going to verbally explain this and then see how you interpret it for your answer on the Google form. But think of it this way. If a material is heated and it ends up expanding or contracting when it is cooled, that it still has the same number of particles in it. The number of particles do not change. What does change is how those particles are grouped together. So if they are getting heated, then they are having it where they are taking up more space. So the volume can change as well as the density. Those two items can change when a material is heated or cooled, but it can never, like, it still has the same mass. You would literally have to get rid of some of that material in order to be able to change the mass. So just keep that in mind. The mass remains the same because it's the same number of particles that are in that material. The only thing that can change would be things like the volume and the density. Now, here it says, what will happen to the brass ball when its temperature drops back to room temperature? Will it be larger than, smaller than, or the same size as before it was heated? So what happens is, in situations like this, it will have it where it's going to, sees it will be the same size as before it was heated, or roughly the same size anyways, because it's returning to the same room temperature. And so with that being the case, it should be able to have it where it now is able to fit through that ring again, because they'll both be at the same temperature at that point. So keep that in mind. It'll be the same size as before it was heated. The molecules will become more tightly packed together, reducing size to what was before being heated. Okay, so that is your answer for that. And then we're looking at the last few questions here. So I'm going to have it where we do a part 3. I'm sorry that this is taking longer, but bear with me. We're going to finish off this document here.